Hello all and welcome to my YouTube channel. So today in this particular video, we are going to discuss about a library called Top2Vec. Top2Vec is a library, or you can say it's a resource where we can use it for topic modeling and semantic search. So Top2Vec is a library also. It's an algorithm as well, where we can do all topic modeling and semantic search, and where we can automatically detect some topic present in the text, and we can use it to generate some embeddings, and we can also use this Top2Vec to vectorize the documents, and also you can detect you can use it to detect a number of topics in a particular text, right? And you can reduce those number of topics into the desired topics that you want. So a lot of the functionalities Top2Vec provides, and most importantly, it's for topic modeling and semantic search. So if you go into this particular GitHub repo of Top2Vec, you can find a lot of things available here, and you can see a lot of benefits it provides, like automatically finding a number of topics, no stop word list required, no need of stemming limitations. So a lot of pre-processing also been taken care here, while taking care of while finding the topics from particular text. So so a lot of things has been done at the back end, and it has presented in a form of library, and it is very good library, I would say, for finding a topic model, for doing the topic modeling. So we can also check onto the algorithm how it works. So there are basically 5 to 4 steps that generally involved in it. So I will go through it once I start with the implementation of this. So I will explain a general implementation, as well as how the back, like how top to work works at the back end. So so this is a general description how it works, and a lot of things has been explained here. You can go through this documentation. It's very good, and it might help you in a lot of things when you work in an NLP world. So you might have been given some kind of for large corpus of text, maybe some articles, maybe some reviews, maybe some set of descriptions from where you want to find the topics, and want to segment out the text into certain topics, and that's where this kind of algorithms will be helpful to make and go through those kind of topics, or so to go through those kind of texts and understand and bring up you the topics for you. So a lot of things can be done, as well as this can be helpful in such kind of use cases in the NLP world. And we have been using this topics to find the topics from the text. So it's very good to use such kind of tools, and it can be very very helpful in such kind of use cases. So before jumping onto the uh, implementation part of Top2Vec, let's understand uh, how this Top2Vec algorithm works at the back end. So there are basically 4 steps that generally work. First, it will generate the embeddings from the documents of the word, the set of text that you're going to pass. So it will generate an embeddings. So embedding can be generated in a form of doc2vec. So you can use doc2vec, you can use BERT embeddings, you can use word2vec, you can use any kind of transformer models embeddings. So that kind of flexibility, plug in plug out of models is very helpful, right? So you can use such kind of embeddings uh, for your models, for a Top2Vec to generate an semantic embeddings, and it will be helpful for understanding the text better, right? So that kind of embeddings can be generated using Top2Vec. So that's the first step of generating embeddings from a given set of corpus of words or documents. Then what it does is it performs dimensionality reduction of those embeddings. So let's suppose if you take BERT embeddings and you generate embeddings of your words by using BERT, then you're gonna get a lot of dimensions, right? Let's suppose it will be 500 total dimensions. So you don't want to get into that number of dimensions, because if you take per word the size of the embedding would be around 500 tall, or it can be more of that also. Then it will be very difficult to maintain such kind of corpus with such kind of embeddings, right? So to reduce such kind of embeddings for a particular word, we have to use some reduction techniques, dimensionality reduction techniques, that will make the efficiency, or that will make the efficiency more, and that will make more efficient to find the topics, which will be faster and will be computationally efficient, right? So hence we are using dimensionality reduction, and here QMAP is the algorithm that is being used to reduce the dimensions of a particular word or embedding. And then once the reduction of the embeddings is being done, then then HTTP scan of a clustering algorithm is used at the backend to cluster the topics and documents into one type of cluster. Similar documents will be clustered around the corners, and then some specific topics will be given to those clusters according to the document that has been clustered by using HTTP scans. So we can use HTTP scan most properly in Top2Vec. We can it is HTTP scan which is being used. But if you want to do it customly, then you can also apply this same approach, and you can build out your own algorithm, right? So, and you can use any other reduction technique, any other clustering techniques. But this is the approach that Top2Vec is using, and I think it's working good here. And that's why this particular package is very good for finding the topics from a particular text. So these are the steps, the general steps. I think very easy to understand. And if you want to understand grammatically, or with some pictures, you can go to the GitHub and go to their description of understanding how this algorithm works, right? So now let's just jump into the implementation part of Top2Vec. So before moving into the implementation, we can install this Top2Vec in varieties of format. So if you go into the GitHub, there are a lot of ways to install this. So if you want to use the BERT embeddings, so you can use the sentence transformer. You can also use sentence encoder, and there are a lot of other indexing models available. So you can use Top2Vec generally. So it is dependent upon what kind of embedding you want. So, and depending on that, you have to perform the installation. So you can basically use sentence transformer installation with Top2Vec, and also sentence encoder. So I have used sentence encoder for installation, and let me just initiate this cell so that it can install. And I have already installed this particular Top2Vec, so its requirements are already satisfied. You may once you run it, you may install it based on your requirement, right? And then you have to import some libraries for the data to be imported. So I'm using Top2Vec from Top2Vec library that we have just installed, and importing basic pandas and NumPy. So let me just initiate this. And for the data, I'm using sklearn dataset, fetch 20 news group. So this is a dataset. You can find it on sklearn datasets. It's available. You can use it, and you can import it from there. And then uh, let us print out this data. So let me just run this cell and get this data out for you. So you can see a lot of news descriptions, and lot of news has been given for like for a particular this news 20 group data set, right? So a lot of articles has been accumulated and been given here. So now we want to understand what kind of news or topics this kind of article belongs to. So let's just see what is the length of this data. Then it's 18,846 article descriptions are present here. That is the news present here. And now we want to train the Top2Vec model on this data, right? So for training it on Top2Vec model, we have to initiate Top2Vec function from Top2Vec library that we have taken, that we have installed. And from inside this Top2Vec, we have to pass the data that we have, the description or the date or the article that we are going to pass here. So the data that you have seen here in news group uh, is we have to be it has to be passed in here, and it should be in a form of list. So all the data inside uh, which has to be passed inside this Top2Vec, it should be present in a form of list. So if you see this particular news group data, you can see it's these all are in a list, inside a list. uh, so let me go at the top. You can see all the text, all the articles are inside the list. It's in a list format. So that's how we have to prepare data for your particular data set that you're going to form. You have to convert your column into the list of the data, and then you have to pass into the Top2Vec. And then these are the embeddings, where embedding model that you can pass. We are using universal sentence encoder that is by default by this Top2Vec. You can also replace with BERT encodings, Roberta encodings. So a lot of models you can use over here. And then once you've done it, once you specify this parameter, so we have to just run this cell, and it will take few seconds to just find the and to run the algorithm and get the word embeddings for us. So let us run this, and then wait for a few minutes. Okay, so now you can see topics has been generated. So if you go through this information that is being printed out, you can easily see that it has downloaded the model, universal sentence encoder model. Then it has created the word embeddings. Then it has reduced the embeddings. So dimensionality reduction has been done. Now it is using SDP scan to find the dense area or to do the clustering of it. And then at the end of this clustering, then it is assigning the topics. So that's how the script has been printed. Also, you can see it has worked in those frame of areas that we have talked about earlier. And once we have this model ready, then we can just understand how many topics it has generated. So you can see it has generated 98 topics out of this text. And let's just view some of the topics in the numerical format. So this this particular get underscore topic underscore size will help us to understand uh, what is the frequency of the topics, and what are the indices or index of the topics. So those right now the topics would be present in a form of indices. So we want to just know about it. So it's just an information about the topics that you're producing. So let us view those information, which is very important. So you can see this topic size gives us some numbers. It is nothing but the frequency of occurring topic 0 is 1666. That's what it says. So it is showing the frequency of a particular topic present in this particular document. And if you want to see the number of topics, so you can see there are so these are the indexes of the topics. So you can see there are 98 topics, and these are the indexes belong to it. And it says that 1666 is the frequency, is the most topic is the frequency of the most occurrence of the topic. So that's the information that you can understand with that, but that is not very intuitive. But you can just use this information and understand in your terms. And you can also generate topics, like for per topic how many words it has been generated. So you can see for topic 1, this is the word, these are list of the words. For topic 2, these are list of words. Topic 3, these are the list of words. Likewise, we have 98 topics, right? So for 98 topics, what are the words? So if you just want to print out the topic 1, the words for topic 1, you can just specify the indices 0. So you can see the topic 0 has these number of words. And so if this number of words found, then it is classifying it as topic 1, right? So uh, and if you want to print out such topics, so you can do it like model.get topics, and you want to print out like 98 topics. Since we found 98 topics, and it will generate topic words, topic score, and topic numbers. And we will zip it around this generate topics, and we'll print out. So let's print topics and its corresponding words. So let's scroll down. So if you go top, can see for topic 0, it has these list of words. For topic 1, it has these list of words. Likewise, it has 98 topics, right? So it will generate 98 topics and corresponding its words. So you can see topic number 66 is all about helmet and safety, bike injuries. So this topic is 66, and likewise, it has topic 67. So it has been done. It has generated a lot of topics according to the words, and that's how you can do it. So if you want to also plot a word cloud with respect to the topics, so let's suppose we want to generate a word cloud for topic number 0. So we'll do model dot generate topic word cloud function and pass the indices. So we'll generate word cloud for topic 0, and it will just plot a graph or plot a word cloud for us. So you can see the same words that we saw for topic number 0. It has plotted now in form of word cloud. You can also access vectors of the topics. So you can see you can also access the topic vectors by using this. So there are just additional functionalities that Top2Vec provide, and you can use it for other processing as well. So that's why I'm displaying it here. So it will be very helpful. Uh, Search for topics by keyword. So these are topics that will help to search the topics by putting up the keywords. So if we pass a keyword like politics, so it will help us to search the topics that has this word politics. So you can do this by using border search underscore topic. This is the functionality, or is a function, and that it takes up the keywords for so it will take the keyword for which you want to find the topic. So if the topic has politics as a word, then it will give us the topic list of the words with the topics politics, right? And you are specifying how many number of topics you want to list out. So right now I'm passing 3 topics should be written with the word keywords having politics, and it will return all this scores and topic words and topic numbers, right? So let me run and show it up to you. So it should print only 3 topics. You can see these are topics having politics as a word. So if you go into this, you can see politically, politics is the word, right? And if you go more down, you can see, let me find it for you, politics. Yeah, right. You can see this politics. So it is returning this topic. These 2 topics has been returned, and you can see the corresponding scores of these topics, right? Word wise topics. So that's how such you can search the topics by using even the keywords, and you can search the document also. Let's suppose if you want to find a document with certain topic, right? So you can also find a document corresponding to topics. So for that you can use model dot search document by topic, and you can pass how many number of topics you want to do. So let's suppose you're like, it's not like how many numbers, it's like I'm giving 48th index of the topic, and you can find the document with respect to the 48th index. So if I go at the top, you can see we have found out the 98 topics, right? So 48th number would be this one, right? So this one. So it will take all this list of words, and it will find the document corresponding to this topics, 40th number topics. So that's what it is doing here. That's what it is doing here. So it will take the 48th index topics or words, and will find out the document corresponding to it. And how many number of documents you want to find it? 5 number of documents. And that's what it will give it. Output, it will be documents, document score, and document IDs. So let us print out this and we'll see how it is actually. So let me run this out. So you can see it has printed the documents with all the words present in 48th topic number, and it has printed 5 documents. You can see the document score, the document that you want to see. Similarly, you can see document number 77, 770 ID and score, and so these are documents. You can get it by using the by passing the topics into this. So you can pass 48. You can also pass 0th topic. Correspondingly, you can find documents. So we are passing zeroth topic words, and we're finding the words for it. We're finding the documents for it. Right. So this is what it is doing. And at the end, I would like to show you an additional facility of Top2Vec, which is uh, reducing the number of topics. So what happens is, sometimes what happens is, model tends to find a lot of topics from a particular text, right? Let's suppose there are, it has found out 100 or 200 topics, but we don't want those number of topics, right? Those many number of topics. We just want a certain number of topics. Let's say 10 number of topics, 20 number of topics, right? So to reduce such kind of numbers, to reduce such numbers of topics, we can use this hierarchical underscore topic reduction method from model, and provide a certain number of topic that we are looking for. So we can specify like, okay, now don't find 1,000 or 100 topics randomly, just find 20 topics. So that's what we are passing the number here, the 20 number of topics. So now the model will actually combine the topics that has been generated into the 20 number of topics. So let's suppose initially it has found out 98 topics, right? So it will now club all the important topics or closest topics into one topic, and likewise it will club all those similar topics into one topic, and it will produce 20 similar topics, 20 different topics. So that's how it's going to be doing it. At that backend, it will club up the similar topics into one, and it will produce 20 topics. So once I run this, you can see the topic mapping. It says that these are the indices that are being used to club the similar topics. So these are the indices of the topics that are being used to club the similar information. And you want to see the topic words reduced for indices 1, then you can also do it by topic word reduction. So if I print it all for 0 as well, so let me just show you. Yeah, you can see this was a 0 topic that we found it out right uh, at the initial cells. So this is a similar topic that we found, but it has been reduced, and it is clubbed into the 20th topic, and it is not showing. So it is not reduced one, right? So this is how you can fully leverage or use the Top2Vec from end to end. And I thought of showing it off to you so that you can better understand what are the things actually it has in its library. And these are different functionality, you can use it for your purpose. It is better to use such kind of functionality so that you can understand data better, understand text better. So these are also a part of text analytics. So it is very important to do such kind of analytics and to understand that corpus, where it belongs to and what it belongs to, right? So hence, I think Top2Vec is very useful for the NLP domain, and understanding the data, understanding the corpus of text that you've been passing. And these are the use cases that have been talked about already. You can use it over there, right? So this is all about this particular video. Hope you liked it. If you liked the channel, do subscribe to my channel. Thank you.